Urmează o prezentare înregistrată de o persoană care s-a distins atât în România cât și în Statele Unite ale Americii, Cloud of Clouds, care imediat va fi pusă on screen.
Deci este vorba despre colegul meu, Mihai Nelu, care a fost vreo 8 ani de zile directorul unui grup de dezvoltare la laboratoarele Bell Labs. A lucrat aici în România multă vreme, adică până în 92. În 92 am fost la lucrarea lui de doctorat și după aceea a plecat în Statele Unite. Și acum, după dezvoltarea sistemului de operare pentru rutere la AT&T în anii 90, atunci când a apărut și Java, a ajuns la un nou concept care l-a patentat de conectarea cloudurilor heterogene.
Hello everybody, my name is Nelu Mihai. I hope you are enjoying the conference and having fun. My presentation is a little bit more theoretical. It's about a project named Cloud of Clouds between one of my startups, MosaicSoft, and Waterloo University, having the goal to create an infrastructure for controlling applications on cloud, multi-cloud, and what is more recently known as supercloud and meta-cloud, and helping the builders of these applications to have an easier life and to navigate this very complex environment using a methodology that is a little bit more structured. And it intends to create a theoretical model of cloud. A few words about the principles of this project. It is about yours truly, the presenter, and Professor Mahesh Punitara. Mahesh Punitara is a professor at Waterloo University. It's a long-time collaborator of mine. I am proud to say that I hired him when I was at Bell Labs and he was doing his PhD. Mahesh is a renowned expert in distributed systems, algorithms, security, networking, and of course, cloud. What can I say about myself? I'm an older guy, so I've been around the block. The project is funded mostly by my personal funding and with some contribution from the government of Ontario. It has a tremendous talented team, mostly PhDs, students and graduates, and it's intended to be an open architecture that addresses the problems in multi-cloud and meta-cloud. Well, this is probably the most important slide of this presentation. I'm trying to define the foundational principles of Cloud of Clouds. First of all, cloud is a programming paradigm which allows builders to design applications with data and logic inherently distributed. It's not a hospitality business. It's not about moving application from customer prem to hyperclouds. Secondly, execution units, data, and interconnectivity are equally important. Most of the cloud designs considered actually execution units and data are the essential part of the design, neglect interconnectivity, which is a mistake. We know for sure that different cloud technologies are heterogeneous, but having in mind this, we shouldn't abstract them using a common denominator approach because this is going to limit their functionality. And if we talk about abstractions, they should be generated from a universal mathematical model, which I call theoretical model of cloud. All of us know that cloud is complex. Therefore, in this design, automation and optimization are essential for all the system. More important than open source is open architecture. Why? Because open architecture allows customers and third-party applications to be very easily integrated in this controlling infrastructure. Meta-clouds is, of course, distributed, but it should be as easy to operate as one single computer. It should be logically centralized. And one axiom that actually I think is very important and people don't give it enough attention, it's the following fact. Independently designed best-of-breed components assembled together or hacked together do not create a best-of-breed system. Now it's time to learn how Cloud of Clouds works. Let's suppose that I have a customer who runs their application on 3 clouds, Microsoft Azure, AWS, and Kubernetes on-prem. What Cloud of Clouds is going to do is interface with these accounts, start to process and discover all the objects that exist in them. And the result of this processing, it's going to be what we call a knowledge hypergraph. In fact, a knowledge base accumulating all the information that is needed in order to characterize these 3 accounts, but in one unified model. So practically every single object in those 3 clouds are described as nodes, edges, and their attributes in the knowledge hypergraph. Of course, the reason we want to have a multi-cloud is to run a workload on it. So let's go to the next steps of the understanding how Cloud of Clouds works. So we suppose that we have a complex workload that needs to be deployed on the multi-cloud using Cloud of Clouds. So Cloud of Clouds is going to use YAML files which describe the configuration and the instantiation of this workload, or a new YAML file can be written. But again, the result of the processing done by Cloud of Clouds is going to be another graph, which we call knowledge graph. So we'll transform this application configuration or workload configuration into yet another graph, which is going to be deployed on the knowledge hypergraph, which was presented on the prior slide. We mentioned on the slide related to the foundational principle of Cloud of Clouds that optimization, automation are the essence of the whole design. So let's examine a little bit how this whole mechanism works. We have on the left-hand side a knowledge graph, which represents the application. Then on the right-hand side, there is a knowledge hypergraph, which abstracts the infrastructure. Clearly, this knowledge graph is nothing else than a flavor of a neural network, providing the input into a deep learning system that can examine what's the current status of the Cloud of Clouds, try to figure out what are the patterns for the future behavior, and then using a prediction and inference mechanism to build a kind of control loop that changes the behavior of the system in such a way and remains on the same thresholds that the user is interested to work with. It's, if you want, trying to make an analogy, similar to the way that industrial systems are managed. So you have a system that evolves, and then you have a control loop that regulates the system based on the desire of the customers and keeps parameters in a certain thresholds. And this gives a very nice and elegant way of running for the whole life cycle of workload applications in meta cloud or super cloud. Well, we are at the last slide of our presentation, where we're trying to extract the essence of the design of Cloud of Clouds. So what we've achieved is to translate, if you want, all the objects and their related attributes from an infrastructure which is multi-cloud with heterogeneous hyperclouds connected to it. We transform it into this knowledge hypergraph, where every single object in the cloud is represented as a node, edge, and its attributes. We did the same thing also with the workloads. So in this way, we generated, if you want, a universal graph that is and represents the state of the meta cloud. In this knowledge system, we have, in fact, three models, sorry. One is a logic model, the other one is a connectivity model, and the knowledge model. So the logic model deals with execution units, The connectivity model deals with interconnectivity relationships, and the knowledge model is really about data and their attributes and how these data is supposed to be used. On top of this infrastructure, we build a set of services that are very useful in a meta cloud, such as security services, scheduler, optimizer, autoscaler, load balancer, an automation engine, and connectivity orchestrator. And by building this computational space, we succeeded to achieve a goal that is very interesting. We created a control infrastructure which doesn't hide the underlying hyperclouds. It keeps them relevant, but at the same time, it controls the behavior of all these applications in the meta cloud using a simple mathematical model that makes the life of application programmers or builders easier, and it adds some structure to this heterogeneity of the hyperclouds.